Hello and welcome to another GCSE revision video, and in this video we're going to be looking at the sine rule. Now for the purpose of this video we're going to use a triangle that is labelled according to the convention that lowercase letters represent the lengths of sides which are opposite the angles marked with the corresponding uppercase letters. So lowercase a is opposite uppercase A, lowercase b is opposite uppercase B, and lowercase c is opposite uppercase C. Whereas uppercase A, B and C are angles, and lowercase a, b and c are lengths. Now for any triangle, the ratio of the lengths to the sine of the opposite angle is the same. So length A over the sine of angle A is equal to length B over the sine of angle B, which is equal to length C over the sine of angle C. So long as you're consistent, it doesn't matter which way up you use the sine rule. So the sine of angle A divided by the length A is equal to the sine of angle B divided by length B, which is equal to the sine of angle C divided by length C. This is because if A over B is equal to C over D, then B over A is equal to D over C. That's because if A over B is equal to C over D, then C over D must cancel down to become A over B. Okay, let's just try an example to see what we mean there. If 6 over 12 is equal to 4 over 8, then 12 over 6 is equal to 8 over 4. In other words, all I've done is flipped both sides. So let's cancel these down and see what happens. So 6 and 12 will both divide by 2. So that becomes 3. And that becomes 6. They can both divide by 3, so that becomes 1, and that becomes 2. So 6 over 12 is the same as 1 over 2. Now let's divide both these by 2 again. So this 4 becomes a 2, and this 8 becomes a 4. And we can divide by 2 again, so this becomes a 1 and this becomes a 2. So they're both a half. We can do the same with these. So 12 over 6, well this time we can be a bit quicker because we're more confident with our numbers. So this can divide by 6, so this becomes a 2 and this becomes a 1. And this we can both divide by 4, so this becomes a 2 and this becomes a 1. So again, 2 over 1 is equal to 2 over 1, and 1 over 2 is equal to 1 over 2. So A over B is equal to C over D. Then that means that B over A is equal to D over C. That's what we're saying. So this is why we can use A over sine A is equal to B over sine B, which is equal to C over sine C, which works just as well if we do sine A over A is equal to sine B over B, which is equal to sine C over C. You can use it either way round, doesn't matter, so long as you're consistent all the way through. It's always best to have the unknown that you're trying to find on the top of the fraction. If you don't, no big deal, it just makes it easier if you do. The only thing to look out for with the sine rule is ambiguous triangles. So even though we have two lengths and an angle, we can't just go ahead and solve the triangle, as there are two possible triangles that could be drawn with the same information. So just remember the previous video about solvable and unsolvable triangles. If you do get a triangle that is ambiguous, you'll need another piece of information. In a GCSE exam, if you encounter a problem such as this, another piece of information will be given to resolve the ambiguity. For example, you might be told that the angle opposite length A is acute or obtuse. Okay, well, so much for the theory. Let's have a go at putting this into practice. We're asked to complete this triangle. So the first thing we want to ask ourselves is, can it be done? Is this triangle even solvable? Well, we've got two angles and a length, so yes, that absolutely is solvable. There's only one unique triangle that can fit this description. So the first thing we can do is get the third angle. Well, 80 degrees leaves 100 out of 180, and that's 40 degrees, so this needs to be 60 degrees. Because 60 plus 40 is 100, and 100 plus 80 is 180 degrees, because all the internal angles of a triangle must add up to 180 degrees. Okay, so we know that this length opposite the 40 degrees is 20 centimetres. Now let's go ahead and label this, let's call this A, let's call this B, and let's call this C. So that means this will be length C and this will be length B. And we can say that, well, let's solve for side B. So B over sine 80 degrees is equal to 20 centimetres over sine 40 degrees. Remember, the sine rule says that B over sine B is equal to A over sine A is equal to C over sine C. So length B is equal to 20 centimetres times the sine of 80 degrees all over the sine of 40 degrees. All I've done is multiplied both sides of the equation by sine 80 degrees. And now we're going to need a calculator. So I have my calculator, and I'll check that we're in degrees, which we are. So this is 20 times 80 degrees sine. It might be different. You might type things in differently on your calculator. You need to make sure you know how your calculator works. And then I divide by 40 degrees sine. And that comes to 30.64. I'm going to round that to 30.6. So B is equal to 30.6 centimetres. In fact, I'm going to put that units in. Okay, now to get length C, C over sine 60 degrees is equal to, let's use A again, so that's equal to 20 centimeters over sine 40 degrees. So C is equal to 20 centimeters times the sine of 60 degrees all over the sine of 40 degrees. And we're going to need our calculator again. Okay, so we have our calculator. So we need to check that we're in degrees, which we are. So it's 20 times 60 degrees sine divided by 40 degrees sine, which is equal to 26.94. Again, you have to make sure you input your information into your calculator the right way round. Just make sure you know the quirks of your own calculator. So 26.94, so C is 26.9 centimeters. But I'll write that down here as well. So we have the missing angle and the missing lengths. Okay, I hope you found this helpful. If you did, don't forget to like, comment and subscribe. If you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in another video.